Evening, everybody. This is Mr. Diego from Mr. Diego Tutoring on Instagram and Crushing Chemistry on YouTube. I'm going to try to make it quick today, under 3 minutes. Today, I brought you a paper 1A style question. It's a stoichiometry and dimensional analysis question, and I'm going to teach you something that I taught my students called math with the units when you're doing dimensional analysis. So let's read the question real quick. What is the number of hydrogen atoms in 2 moles of NH3, and it gives you the Avogadro's constant? So basically, the first step is start with what you have. So you have 2 moles of NH3. Just write it down. You don't want your answer in moles of NH3. You want your answer in hydrogen atoms. So first, we need to look at the structure of NH3. For every 1 mole of NH3 molecules, I have 1, 2, 3 hydrogen atoms. So if I have 2 moles of ammonia molecules, NH3, I'll have 1, 2, 3, 4, 5, 6 moles of hydrogen. So I have 6 moles of hydrogen atoms for every 2 moles of NH3. Include that over here. So you don't want moles of NH3, but moles of NH3 in the denominator. So it cancels out and you put moles of hydrogen in the numerator. Cancels out over here. You still don't want moles of hydrogen. So what you're going to do, you are going to do another fraction. Since you don't want moles of hydrogen, you're going to put moles of hydrogen on the bottom. And you want actually, now what number should we populate here? We know that there are 6 moles of hydrogen for every 2 moles of NH3. And we know that there's 6.02 times 10 to the power of 23 atoms, molecules, whatever, for every 1 mole of hydrogen. So moles of hydrogen cancels out with moles of hydrogen. I already know the unit of my answer. It's going to be in atoms of hydrogen. So I don't have to worry about that anymore. Now I just have to do the math. This number 2 cancels out with this number 2. All we have left is to multiply 6 by the Avogadro number. So I'm going to do 6.02. I'm going to leave the 10 to the power of 23 to the side. I'll adjust that later and I'll multiply that by 6. The result is going to be 36.12 times 10 to the power of 23. We know that the number here has to be between 1 and 10. So I need to move my dot to the left. If I move to the left, I add. Because I moved it 1 spot to the left, I am going to add 1. Therefore, my result is going to be 3.612 atoms of hydrogen. Alternative D that